Dear students, welcome back to physics class. Today, I would like to introduce new topic, elementary concepts of differentiation and integration for describing motion, part D. The subtopics are A. Kinematic equations or relations for uniformly accelerated motion and B. Numerical, part A. For today's class, I am going to discuss on very important section which is kinematic equations or relations for a uniformly accelerated body. First you have to know about what is kinematics. Kinematics is a branch of physics which deals with the study of the geometrically possible motion of a body or system of bodies without reference to cause of motion or without consideration of the force acted on the body or bodies. It is a part of mechanics. I told about mechanics. What is mechanics? Mechanics is an important part of physics. You please note this point. Our life supporting our own company, Jindal Sol Limited, whose important foundation, the employees whose most part of the service is the mechanical engineering work. Now, I think you can understand about the importance of studying the kinematics and present running chapter. At first, you have to consider a uniformly accelerated body whose displacement in time t b x, initial velocity b v0, final velocity b v, and acceleration b a. These physical quantities all are interconnected or dependent one on another. So it is possible to derive some simple equations that relate one quantity with another quantity. Here, displacement x, time taken t, initial velocity v0, final velocity v, and acceleration a are interrelated. These equations of motion of a uniformly accelerated body is called kinematic equations or relations of the body. The equation V is equal to V0 plus AT gives a relation between final and initial velocities V and V0 of an object moving with uniform acceleration A. This is called first kinematic equation of motion of a uniformly accelerated body. Now, we are going to derive first kinematic equation V is equal to V0 plus AT graphically. For this, you have to consider a uniformly accelerated moving body whose velocity time graph is given in this figure. You have to take the slope of this given graph of the considered uniformly accelerated body which gives acceleration. This is one important application of velocity time graph or VT graph. Here, initial velocity V0 is non-zero. What should be the slope of the given graph AB, which can be determined by using the mathematical expression y2 minus y1 divided by s2 minus x1, which you studied in previous class. Here, the slope of the graph is equal to y minus y0 divided by t minus 0, where y2b v, y1b v0, s2b t, and x1b 0. So, acceleration a is equal to slope of the graph is equal to V minus V0 divided by T, which is the equation A. From given equation A, AT is equal to V minus V0, then it can be written as V is equal to V0 plus AT, which is the equation number 1. Then we have to derive the second kinematic equation x is equal to V0t plus half AT square graphically. In 9th grade class, you had studied the second kinematic equation as s is equal to ut plus half AT square. In the place of s, we have used x, and in the place of u, we have used V0. We have to consider the same situation where the body is moving along a straight line with uniform acceleration, whose initial velocity be v0, which is not is equal to 0. You had studied another important application of velocity time graph from previous class. What is that? Which is area enclosed by velocity time graph with respect to x-axis or time axis gives the distance traveled by the body in the corresponding time interval. Again, we have to consider the same graph which is shown in the figure. The area under the graph is area between the time instants 0 and t, which is equal to area of the right triangle ABC plus area of the rectangle OACD as shown in the figure. Then distance traveled by the body x is equal to 1 by 2 into AC into BC plus OD into CD, which is equal to 1 by 2 into BC into OD plus CD into OD, where BC be V minus V0, OD be T, and CD be V0, which are obtained from the graph. Then, by putting this value, this expression will become as x is equal to 1 by 2 into V minus V0 into T plus V0 into T, which is the equation B. The area under the velocity time graph represents the displacement of the moving object. Then the displacement traveled by the body x is equal to 1 by 2 AT square plus V0 t, which is obtained from the equation B, since V minus V0 is equal to AT or V is equal to V0 plus AT, which already we have derived as first kinematic equation. Here we have put the value of V as V0 plus AT in previous expression. So it will take the form of x is equal to V0t plus 1 by 2 AT square, which is the equation 2. And we have to derive the third kinematic equation, which is V square is equal to V0 square plus 2ax graphically. For this, we have to consider the same graph again. The area under this graph is distance traveled x. Then x is equal to area between the time instants 0 and t, which is equal to area of the right triangle ABC plus area of the rectangle OACD, which is equivalent to area of the trapezium OABD. Then x is equal to 1 by 2 into BD plus AO into AC. You know that area of trapezium is equal to 1 by 2 into sum of measures of length of two parallel sides of the trapezium into perpendicular distance between these two parallel sides. Then x is equal to 1 by 2 into BD plus AO into OD. Here the two parallel sides are BD and AO, and AC or OD be the perpendicular distance between these two parallel sides, which is equal to 1 by 2 into BD plus AO into OD is equal to 1 by 2 into V plus V0 into T is equal to 1 by 2 into V plus V0 into V minus V0 divided by A. Since V is equal to V0 plus AT, then T is equal to V minus V0 divided by A. So, the equation will become as x is equal to 1 by 2 into V plus V0 into V minus V0 divided by A. It will take in the form of V square minus V0 square is equal to 2AX, since V plus V0 into V minus V0, which is in the form of A plus B into A minus B, is equal to V square minus V0 square as A square minus B square. So, x is equal to 1 by 2 into V square minus V0 square divided by A, which will take in the form of V square minus V0 square is equal to 2AX. Then V square is equal to V0 square plus 2AX, which is the equation 3. Next, you are going to study about an alternate method to derive the third kinematic equation, V square is equal to V0 square plus 2AX. You know that displacement traveled by object which is in uniform accelerated motion, x is equal to average velocity into time, which is equal to sum of initial velocity and final velocity divided by 2 into the time taken by the body, is equal to V0 plus V divided by 2 into T, which is the equation C. When an object is in uniform accelerated motion or non-uniform motion with equal change in velocity, its change in velocity is always uniform. Its average velocity will be equal to arithmetic mean of initial velocity and final velocity. Then average velocity can be expressed as V is equal to V0 plus V divided by 2. As time t is equal to V minus V0 divided by A, which is obtained from equation 1, then the equation C can be written as x is equal to V0 plus V divided by 2 into V minus V0 divided by A, which is equal to V plus V0 by 2 into V minus V0 by A, which is equal to V square minus V0 square divided by 2A. Then V square minus V0 square is equal to 2AX. So V square is equal to V0 square plus 2AX, which is the alternate method to derive this equation. The three important kinematic equations are, first one is V is equal to V0 plus AT, second one is x is equal to V0t plus half AT square, and third one is V square is equal to V0 square plus 2AX. You must study these equations. What is the general form of kinematic equations? Consider x0 be the position coordinate of a uniformly accelerated moving body at time t is equal to 0, which is non-zero. That is, x0 is not is equal to 0. Then the last two equations are modified by replacing x by x minus x0. Since displacement is change in position, here x minus x0 is the displacement traveled by the body in the time interval 0 to t. The modified form of equations are v is equal to v0 plus at, which is the equation for x is equal to x0 plus v0t plus half at square, which is the equation 5, and v square is equal to v0 square plus 2a x minus x0, which is the equation 6. At last, we are going to the numerical section. First question is, a car is moving along a straight line, say OP in given figure. It moves from O to P in 18 seconds and returns from P to Q in 6 seconds. What are the average velocity and average speed of the car in going A from O to P and B from O to P and back to Q? First, we have to find the average velocity and average speed of the car in going from O to P. Average velocity is equal to displacement divided by time interval, which is equal to plus 360 meter divided by 18 seconds, which is equal to plus 20 meter per second. And you studied that average speed is obtained by the total path length divided by the total time taken, which is equal to 360 meter divided by 18 seconds is equal to 20 meter per second. Here the car starts from O and reach at the point P. Here the average speed is equal to the average velocity because the total path length is equal to the displacement traveled by the car. And in second case, when car moves from O to P and back to Q, the average velocity is equal to displacement divided by time interval. As shown in figure, the displacement be OQ. Then it will be equal to OQ by delta t, which is equal to plus 240 meter divided by 18 plus 6 seconds is equal to plus 10 meter per second. As displacement is change in position, it will be equal to plus 240 meter. So, average velocity is equal to plus 10 meter per second. Then, what should be the average speed? Average speed is equal to total path length divided by total time taken, which is equal to OP plus PQ whole divided by delta t is equal to 360 meter plus 120 meter whole divided by 24 seconds is equal to 20 meter per second. Here average speed is not is equal to average velocity. As the car undergoes change in direction at the position P, so the path length is greater than the magnitude of the displacement. Second question is, a woman starts from her home at 9 a.m. walks with a speed of 5 km per hour on a straight road up to her office 2.5 km away, stays at the office up to 5 p.m. and returns home by an auto with a speed of 25 km per hour. Choose suitable scales and plot the ST graph of her motion. Here given that speed of the woman is equal to 5 km per hour. The distance between her office and home is equal to 2.5 km. You know that time taken is equal to distance divided by speed. So it will be equal to 2.5 km divided by 5 km per hour is equal to 0.5 hour is equal to 30 minutes. It is given that she covers the same distance in the evening, which is 2.5 km. Speed of the auto is 25 km per hour. The time taken is equal to distance divided by speed, which is equal to 2.5 km divided by 25 km per hour, which is equal to 6 minutes. The suitable ST graph of the motion of the women is shown in the given figure. And third question is, a car moving along a straight highway with a speed of 126 km per hour is brought to a stop within a distance of 200 meters. What is the retardation of the car and how long does it take for the car to stop? Assume that the car is the uniform retardation. Given that initial velocity of the car V0 is equal to 126 km per hour is equal to 35 meter per second. Final velocity of the car V is equal to 0 and distance covered by the car before coming to rest x is equal to 200 meter. We have to find the retardation produced by the car and time taken by the car to stop. At first, we have to use the third equation of motion to find the retardation produced by the car. We know that v square is equal to v0 square plus 2ax. Then a is equal to v square minus v0 square divided by 2x, which is equal to 0 square minus 35 square divided by 2 into 200 is equal to minus 3.06 meter per second square. Next you have to find the time taken by the car to stop. We have used the first equation of motion, which is v is equal to v0 plus at. Then t is equal to v minus v0 by a. By substituting the values of v, v0 and a, we get t is equal to 11.44 seconds. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.